Ladies and gentlemen.
Welcome to the Reliability U podcast with Brett Scott and Adam Lunt, where we talk about all things reliability. Stay tuned. Welcome back to the Reliability U podcast, where we're going to talk about all things reliability. As usual, I'm your host, Adam, with...
Brett Scott, how you guys doing?
So, Brett, how's things going for you this week?
Doing good. Just finished up yet another week of training. Getting all kinds of people out there a little more educated on some
Awesome.
of these crazy topics. How about you?
Not bad. Actually got a couple days in the office this week. It was kind of nice. I always like being home a day or two, but then after that, I don't know if I told you guys previously, I have 4 kids and 2 of them are 2-year-old twins. So any excuse I have to go stay in a hotel is,
Yeah.
sometimes it's not the worst thing ever. But yeah,
Well, and we're both parents, so yes, you have the young ones. I've been there. I've got the older ones that are actually adults, and I use the same excuse to get out of the house. So it seems like it just never ends, but
they're assholes at every age
exactly,
is
exactly.
pretty much what you're getting at.
Yeah, you said it. I didn't, but I'm gonna nod and say yes. Yeah.
Fair points. So, as far as topics, kind of circling back from all the conversations we had last week, I feel like we started a lot of different topics and then intentionally, kind of put the kibosh to them
Yeah.
before we got off into the weeds because we have so much to talk about over so many different episodes. And you and I got together here 3-4 days ago, went out and had a couple drinks, and we're coming up with ideas for people to have on the podcast, topics we want to talk about. Obviously, we want feedback from everybody listening to on, if you have a recommendation or a suggestion on who we should get on, or a topic we should cover, we can, kind of put the feelers out there and see who would be a good guest to do that, because we'll say it again, reiteration is key here. We're not the experts, so we're going to find those experts. Because you and I can sit here and feed a line of bullshit for hours, but it's not something I'm wanting to do. One of the topics that we had brought up previously was as far as like communicating with artificial intelligence, because everyone hears about AI, excuse me. They talk about AI, how it's gonna change the industry, how it's a complete game changer. Now, I'd like to hear your thoughts on it. My personal opinion is AI is a fantastic assistant
Yeah.
in certain realms of reliability, vibration, for example. AI can definitely help speed up the analyst's job,
Right.
but it's not, and I'm not going to say it's never going to get there, but where it currently sits, AI is a far cry from being able to replace an analyst.
Yeah, I agree, and I just had conversations with some students this week about that. Everybody always asks, with all these different sensors on the market, you've got all these wireless and wired sensors, and now they're being connected to AI. What's that mean for the Vibe guy in the future? And it's a good question because people, some people are, with reason, a little bit worried about it too. Like, am I going to be able to be employed, or is AI going to take over? I feel like personally, it's similar to what you're saying. I think it's a great assistant right now, and we're building it, we're teaching it. This generation of vibration guys are going to be the ones that are going to learn from it, and it's going to learn from them. And that's going to kind of determine how it ends up in the future. But I think personally, although technology does seem to exponentially ramp up, and like all of a sudden, you look at our America, or not even America, but human history. There's like 50-year span where we went from steam engines to electricity all over the country. It's the same thing with AI. Right now, it's not where it needs to be. Will it be there, in our lifetime? Maybe. But right now, I feel like no. I think in my lifetime, which of course is less years than some of people maybe listening to this, but I still think that our jobs are going to be safe as far as there still has to be a human involved to work be the medium between the AI and the final product. And I think that's going to happen for quite a while. It's hard to judge, though. Who knows?
It is. There seems to be a pretty steady uptick in the ability of AI,
Yeah.
but like you said, it's definitely not there yet. But we don't know where is that line that we cross where, okay, now it's sentient or whatever you want to call it,
Right.
which I don't want to say it's sentient. I mean, I don't want to go into like a whole
That's a
conspiracy theory
that's
of
a whole
AI.
other podcast. That's a
It
whole
is,
other movie, actually.
but at what point is it now smarter than us?
Right.
The-
Yeah.
And right now it is. It's a good tool, and when used properly,
Yeah.
I think it can add a ton of value.
Well,
I
and even
just
talking about the step before AI, just getting all these sensors in place. There was a lot of conversations happening between, upper management and the guys actually out collecting the data and analyzing the data. There's a lot of conversations going on of what's this mean for us? And like, um, a lot of people didn't want to use sensors for a long time because they were worried that you're removing the human element from collecting data. So that sight, all your five senses, your sight, your smell, everything, when you're out there, the Vibe guy kind of has a little bit of a touch to the equipment. He's used to hearing and seeing and smelling what it's normally like. And then all of a sudden, you've got an AI and, well, not even AI yet, but you've got wireless sensors doing this for them. And a lot of people are afraid of that. But
yeah
I would say on that argument that we're not removing the human element yet. Most of the places that are getting these sensors, they're actually getting the sensors, and then when something comes from the sensor to say we need to look at this thing, they're still sending somebody out there. And I
yeah
think at least the next decade, personally, I would just put my neck out there and say maybe the next 10 years, that's still going to be pretty similar to look from here for the next 10 years, is that we're using them more and more, but we're going to build that trust. And by building that trust, I mean, we're going to double check everything it says, and it's going to double check us too.
I was in that camp, being a vibe guy for a long time. I was definitely team route based human.
Yeah.
As I think all vibe guys were. Now you learn as you go, and I'm starting to find out that maybe it does have its place, and now I'm fully convinced it does as a supplement, not as a replacement. Um, but I'll also back up a little bit. You said the analysts can go out there; they got the five senses. I got to correct you on something. Four senses. I don't want people tasting shit.
Oh, yeah, good point.
So
We don't want to
just
promote that.
so
Yeah, yeah.
feel, hear, see, touch. Yeah,
Yeah.
I get
Well,
all those.
and even
It,
for some of the safety guys out there, the feeling part of it, don't feel stuff that's
true,
rotating.
true. Yeah,
Keep your hands in gloves and where they need to be. But yes,
keep your
good
keep
point.
your arms, legs, and tongue inside the
Yeah,
ride at all
at all
times.
times, please. Yes,
Right.
yeah. No, good
But
point. But you know what I'm saying. Having somebody there,
100%,
it is.
100%.
That's always been some of the people's like most concern is like as soon as I remove the human element, this is technology nobody trusts yet. Someday we'll build this trust and we'll be able to do it. But right now, it can do a lot of things faster than we can. I'll admit it. I'm probably going to lose a race against AI. But the thing is that it does a very good job of quick thinking on its feet. It doesn't show up to work hungover. It doesn't decide it's going to come in late one day. It's
Yeah.
there all the time and it's seeing things over and over. It's going to get there. It's just not yet. But it's really
It,
close.
and oddly, and this was probably 12 years ago. I'm guessing 10 years ago. I don't know exactly. I was out in New Jersey at my in-laws' house. Excuse me. And their neighbor used to be, rest in peace. He passed away here about 3 or 4 years ago, but he was a movie critic for Rotten Tomatoes. So we would always we got there for like Thanksgiving, Christmas, etc. And he would bring down all these movies that were like not even in theaters yet, so we could watch them. And of
Do
course,
you
you
want
get
to say this online?
he's gone now. So I mean, does
Okay,
it
yeah,
really matter? I mean, what are
it's
they going to do?
fine.
Fire him? I mean,
Yeah,
eh,
yeah, exactly.
absolute great guys. It was Cam, and he brought this movie down, and I'm sure some people have seen it before, but it was called Her, I believe was the name of it.
Yeah,
It was where the guy, so I think it was Scarlett Johansson played
yeah. And
um
Joaquin Phoenix,
played
right? Was the
yeah
lead in
played
it?
like Siri or whatever. So crazy they predicted the future.
Yeah,
I mean, really, they did.
they kind of
And
did.
it's just nuts to me. I think I mean, we might have even talked about this previously, but it was such a crazy thing to me to watch that. But that's really where AI,
Yeah,
I think, is going, and I think it will get to that point.
yeah.
I just don't. But just like the P to F curve, how long is it going to
Hmm.
be? I mean, we don't know.
Exactly.
We know where we're trending, and we know where we're going to end up.
Yeah,
But it could be 60 seconds, 60 decades. We don't know.
exactly. Yeah.
It just depends.
The x-axis is very unpredictable on the P to F curve. That
And
time thing can be weeks, months, years. That is the unpredictable part. And you're right. That's the way with this too. We just don't
so
know, quite know the length of time.
so I think we're now calling it the DIPFAI curve. Could we
Design,
trademark that?
yeah, design,
Design,
installation,
installation,
potential to
yeah,
failure, and then what was your A here on this?
AI.
Oh yeah, yeah,
Just AI, man.
yeah. You got. Well,
We're,
then we better throw the I on there too.
yeah, we're
DIPA, A or
a
IAI. Yeah,
yeah, whatever
whatever.
it is. I don't know. But anyway,
Anyway,
so what are we drinking tonight, Brett? Tell us about
we're having some bourbon. What this was Dickel, 8 year
Dickel 8 year.
aged. Yeah,
It's
it's pretty
very
smooth.
good. Pretty
Pretty
smooth.
smooth. Pretty good.
Good once the ice melts a little bit.
Yeah, yeah. It's a little harsh on the start, but with
And
a
as long
little.
as and I'm not paying $4 for my ice tonight, so I'm happy.
Yeah.
Not gonna call anybody out, but that's happened to me at a few bars.
Well, all this
Um,
talk of you and I talking about AI, should we bring on then the guy that knows way more than we do about it?
well,
Is it
and,
time to do that?
I think it probably is, and I would arguably call him an expert in this field. I believe. Known the guy for years. He's been around. I'm sure anybody who can spell reliability knows this man, or at least knows of this man. Uh, he gave me my he actually proctored my CRL exam for me. He's a CRL himself. He's a CMRP, a CMRT, CAMA 2, um, World Series MVP. I mean, the guy is, you know,
He's John of.
if Ramesh ever steps down as the reliability Sherpa, we know who the guy stepping in
We
to take his place is.
got the
So,
backup.
if you guys could give a round of applause, warm welcome for Mr. Paul Crocker.
You're welcome, Paul.
All right, guys. Well, thank you for having me on. Been looking
Thanks for
forward to
coming on.
this. Not much.
Hey, it took a little bit of rescheduling along the way, but we got here.
Yeah, it works.
How's things going for you?
Yeah, it's looking good on my screen. So hopefully the content will be easy to see and easy to hear and entertaining for folks. So,
Perfect. So where are you at today?
at the Lake of the Ozarks,
Nice.
sitting on my back porch. I would have rather had the camera facing the lakeside where I'm looking at, but then I just like a black silhouette, so I didn't. I had to turn it around the other way. But you get to see my signs behind me about the
Yeah.
I do like those. Those are very fitting,
Classic.
to
Yes.
say the least. So you down there all week?
um I don't know. We might go back Sunday or Monday. We might stay here too. I haven't decided yet. So
Okay.
we usually just come for the weekends and then go back during the week. But
That's only what, a couple hour drive for you?
it's about 2 hour 45 minutes. No matter how
That's
fast
not
you
bad.
drive, I've tried doing 80 and 65s, and it's like almost always 2 hours 45 minutes, no matter how I do it. So I just give up trying to blaze down here.
Well, I would assume that a majority of that time is that road going to your house off of 5.
That's a big chunk of it. And
That's
then
like 25 minutes to go like 2 miles.
yeah. And then once you turn off on the little street that comes down to where I live, it's a 10-minute drive. You
Right.
know, you look like you're driving off in the woods and you're going to be hearing banjos any minute or something. You know?
Uh-oh.
Fair. Well, hey, thank you for coming on this, Paul. Brett and I have been talking a little bit just about where AI is going, and I think the fair outcome of that is nobody really knows.
Right?
Um, just like to kind of see what your take on it is, as far as we were talking more specifically on vibration.
Right.
Okay.
When it comes to the analysis side, how can vibrate, a lot of these companies out there are touting, we have AI, therefore you no longer need an analyst,
All right.
which I think we can all here collectively agree that's bullshit.
Right.
At least for
Um,
now.
for now, yes,
For now,
exactly.
yeah, yeah.
That could change, but as of right now, no. But it can be used as a tool for the analysts,
Absolutely.
100%. But just as an overall scope, take vibration maybe not out of the equation, but let's not focus on solely vibration. Where do you see AI in reliability tech today?
Really more of a helper tool to speed things up. Something that may have taken you an hour or 2 hours or maybe all day before, looking at data. Hey, I'm missing something here. And you literally ask it, what am I missing here? Out of this obvious stuff that looks good. And I think with its machine learning capabilities where you're not doing like chat GPT stuff where you're talking into a general chat prompt, you're uploading real data to it with time waveform and timestamps and all the other stuff that will go into it. I think it has a really good chance of being able to decipher that. Now you have to teach it like all the same stuff you would have to teach a vibration guy. Otherwise, it's not going to know what it's looking at. But there's definitely some companies out there I know of that have, I think, done it pretty successfully. Um, uh, MotorDoc, with his empath system, sort of does that. He uses it on windmills and turbines and all kinds of stuff. And he's got a machine learning algorithm in there. You have to tell it some things, but then after that, it just goes and can report on all kinds of stuff. So
Okay.
I think there's some good examples out there. There's some other ones. I'd say, by and large, if you see a company come out and say, yeah, I can do this, it's probably more marketing hype than it is reality. I'd say at the end of the day, there's a lot of marketing hype around AI and its capabilities. But it's got some really cool stuff it can do, so
Well,
I can't
Adam and I,
discount it.
we're kind of in the field where we see it in the like mostly predictive side of things. Like you said, a lot of times vibe, but like, do you see it other places other than just the predictive side of things where it's actually coming into play more often?
I don't know. I've thought about before dropping in some files from like a RCM study and just having a look at it and say, okay, what have I missed on this? What have I got right? What is my analysis of this right? And just see what it says. I haven't tried that yet, but it might be something interesting to see what it could do with the pheromones effects analysis and sort of process FMEA RCMs to see what it does with it. I think it might be some interesting results. It might be totally off the charts and not useful, but I look at it as a tool to just help me get stuff done faster.
Yeah. It's early for a lot of these, technologies, and there's so many versions of it. You have Google AI assistants, you got Grok, you've got all these, Apple versions. But I don't know. Have you guys had experience with one of those more than others? Either of you?
I've used them all. I think my two go-tos are probably Grok and Gemini, which is Google's.
Oh yeah,
Gemini's gotten really good at picture editing capabilities, like really specific stuff. Like I uploaded a picture today of a gas station during the daylight, and I said, "Hey, make this, edit this to make it nighttime. I want lights like shining from the canopy on the gas pumps, and I want the current banner that's just over the canopy, the rain canopy over the gas pumps. It has the company's name on it. I want that lit up like lights are shining on it." And about 30 seconds later, it did exactly what I asked. Like I was out there at night taking a picture of it. So some of them got some really cool capabilities. Grok's is more fantasy.
And Grok,
like
is that the Elon Musk version?
Yeah, Grok. Okay. Yeah, Elon Musk owns XAI. It's XAI's product. So
I've
just
used it a few times.
Yeah, at the consumer level, I think it's really good. I think when you step up to enterprise price range, I think it gets a whole lot better. But we'll see with the next version. I mean, they've been pushing some benchmarks on Open Router and stuff that are better than everybody else's. So we'll see how that translates. It's already good at medical stuff. You can say, "Hey, I'm doing this and this and this," and it comes up with some decent answers. Not that I would use it for a doctor, but it's not bad.
So Elon, if you're listening, we're giving you a pretty big push here. So we'll take some money. That's all I'm saying.
Hey, he's listening.
I'm sure he'll be advertising on the Reliability U podcast
Right.
by the end of the week.
Sure.
So aside from like
Oh
we
wait,
were talking,
I know another
yeah, go
good.
ahead.
I know another good use case. It's really good at pulling apart PDFs and manuals. So if you have a
Okay.
PDF of a user manual, you can like usually say upload this. Your role as maintenance supervisor. I want you to pull out a job plan from this O&M manual on changing some part, and it usually does a pretty good job of um,
Hmm.
laying that out. I mean, it would be a lot faster, and I could flip through the pages and look through it, and retype it or copy and paste out of it. It's does a decent job.
Kind of makes you wonder too if it couldn't be used eventually for like PM optimization.
Oh yeah,
Like you tell it that here's what we're currently doing. What's your opinion to how to make this sleek and more to the point?
yeah.
Because a lot of people are trying to do that.
Yeah, I think you could drop in, work order dates. Say, hey, this is when the failures happened. These were the things that failed on
Yeah.
these particular dates. Calculate the uptime, downtime, all that stuff from that. Like, I'm sure it could do it. I haven't tried it yet, but I'm sure it could do it.
No.
So I guess what's your opinion too? Because AI being, non-industry specific, just across the board.
Right.
I mean, because AI is used in everything from, automotive to medical to, you know, high school kids writing their senior papers. I mean, it's used for everything. And reliability in a nutshell is such a niche field. Do you feel like we are lagging as an industry that we're in because the data has not been fed yet?
That's probably something that's I would say is probably true, because most of the GPT models are built off of learning exercises from books and manuals and publications and websites and whatever.
Mhm.
I would have a hard time saying it's got a gigantic library of RCM books that it's read through, but you never know. I don't know where they get all this data when they do their model training, but I've seen somewhere that a lot of times the big companies haven't really paid for that data. So if companies come after them and say, "Hey, you have our copyright stuff," you've we know that because we can use GPT to tell us about this particular book or whatever, and it has all the data in it, and you can only have that if you paid for that content. So I think it's a challenge that these companies have in their background, and they're trying to work around it because they have a lot of information that I think um, if we had access to, we would have for sure had to pay for it.
Sure.
So they don't just get it free because they're a big company with AI.
But I'm sure they try.
Oh yeah, I'm sure they try.
You got to throw a little bit of weight around and say, yeah, but my name is X, therefore. And I don't mean X specifically, like formerly known as Twitter X.
Yeah, right.
Just it was a placeholder.
Yeah,
Just
I think it
yeah.
was. I think it was one of the countries overseas. I don't know if it was Denmark or what. They have made it to where your personal characteristics, your face, voice, things that you produce, can
Mm.
all be sort of trademarked and copyrighted, so AI can't use it. And if it does, then you can sort of go after them. I've seen some stuff on that
Really.
lately. I would see the United States taking a long time for that to happen. We tend to let stuff go and then deal with the aftermath because we didn't do it in the first place. But
Yeah, well, that's an interesting topic too, because like with all this stuff being fairly new, is like what kind of legislation has
yeah,
not been built
his
yet that's going
legislation
to
is
have to be.
it's by no means caught up, like at
Yeah,
all. And I think that's sort of a dangerous. Personally, some of the stuff AI can do is pretty scary. Like if you can put somebody's voice to some other thing and it
yeah,
sounds like them, you can make it look like them, like the video. So
yeah.
I
There's
think
been
those things
scams
in
built
of
around that.
themselves are a little bit frightening at that capability. The AI itself doesn't understand that's what it's doing, but
Right.
the people using it for sure understand what they're doing with it. And, I guess that's where the problem is the human nature for evil, is not out of the equation with AI.
Yeah,
So
it's true. Because, like you said, it's more of an assistant right now
mm-hmm.
than it is its own thing. But at
Yep.
some point, it's going to be. But we're the people currently feeding it with all this stuff. And
Yep.
if we feed it negativity all the time, it does make you worry a little bit about how it's going to be used in the
Yeah.
future.
If I was an enterprising criminal, you can, I'm sure there's lots of ways you could sort of use it to help you do some things you probably shouldn't be doing, or probably couldn't do, other ways.
I look at it we'll go back a little bit to what you stated about, some of these companies are saying, AI is replacing the analyst, and you're 100% right. It's a marketing thing. I
Mm-hmm.
get it. They're trying to sell their service, their product, their
Right.
hardware, whatever it is, which brings up an interesting topic. So we'll use vibration as an example because it's the most obvious. Company A comes in here and says, we have this online system or whatever, or even a route-based system for that matter, and we're going to run this through our dedicated AI program for analysis, and we're going to spit you out a result. And it's flawless because we've tested it, we fed it the right data. Well, we all know there's a lot of room for fuck ups in there, and that's all there is to it. But what I like to retort with at the end of the day, if AI makes a wrong call, who is legally responsible for that?
That's a good question.
Is it the company that installed it? I mean, if AI says you have a stage 4 bearing defect at its critical level, we must shut down immediately, blah, blah, blah. And the customer goes in there against scheduling parameters, shuts this piece of equipment down, they're losing
Oh,
$20,000 an hour to not
right.
be processing, to tear this thing apart and find out there was actually nothing at all wrong with this piece of equipment.
Error. Yeah.
Yeah, who's footing that bill?
Yeah. I,
Where because I
I
look
just,
at it, I kind of akin to self-driving vehicles.
right.
You got a self-driving car and the car has a wreck.
Yeah.
Who's responsible? The manufacturer of the vehicle, the software manufacturer, the person who allowed it to self-drive, i.e., the driver. I mean, it's not really a driver anymore, but the operator of the vehicle.
All
So
right.
I think it opens up a whole Pandora's box for who the hell are we going to sue?
That's, well, I can see that entirely being possible. I'd say, in an industrial manufacturing environment, you can sort of have that there as sort of your look ahead. I think,
Yeah.
using AI for that. But I think it's always okay. Well, great, great. You gave me an alarm on that. Let me go look at it and make sure that's really what it is. You could walk out there and find out the vibration. The accelerometer's like falling off
Absolutely.
because somebody glued it on, or it was magnetic, and somebody bumped it. And it.
Yeah.
And it fell off on the floor, and it's just sitting there bouncing on the floor, and really nothing that they need to shut it down for. They just need to disconnect the accelerometer until it's done running and put it back together.
And how many times have we seen that, Brett, with triaxial sensors where they get bumped, they don't get knocked off, but they get turned 30
Yeah.
degrees,
Well, or they get
and all
knocked off
the
but put on wrong. Yeah.
or they're
Absolutely.
installed incorrectly from the get-go. And at the end of the day, these sensors, they're collecting data, but they're only collecting one type of data,
Mm-hmm.
like the vibration data.
Yeah.
An RTD is only collecting temperature data, et
Right.
cetera, where the human being is collecting, which Brett and I were just talking about this before you came on. Brett had made a comment, he goes, using the five senses.
Mm-hmm.
That's something a sensor can't do. I had
Right.
to tell him only four senses. We don't want you tasting shit. Keep
I
your
guess
tongues off of
I
machines.
I will stop doing that. I appreciate the feedback. I will stop
More
tasting.
senses only. But
No more
but
tasting grease. Okay.
but
Go.
he's 100% right. Well, he's 80% right. He was 20% fucked up because he said taste. But
Sure.
realistically, he's correct in saying that, because you can't. I mean, if you go out with whether it be just an overall acceleration, just a vibrometer, or you have a full-blown spectral analyzer, or anything down from, a $29.99 Harbor Freight temp gun, clear up to a full-blown $50,000 FLIR T10,000 camera,
Right.
it's just a meter, and it
Right.
only checks this. It's checking one technology. It's checking, thermographic imaging, your energy, it's checking vibration levels, it's checking whatever,
Right.
but it can't do what the human can do.
Yeah, and it's
Well,
not. They don't have much on the way of intuition, So I'd say an AI can know exactly the data that's coming in, but it doesn't really necessarily understand the operating context or what else is going on around it, or budgets, or what time of day it is, or if there's a shift,
yeah,
involved. So
Right.
you got to have that human component. I think, like I say, I see AI best used as a tool to help you get stuff done. I wouldn't ever turn over the keys to it and let it run things. I just
not
wouldn't.
yet.
Technology's never been perfect. Even like for computers, I don't trust them. Like when I go to a conference, I've usually uploaded the PowerPoint deck to them or whatever, but I always have a backup in my pocket on a USB drive. I usually have a second computer because it, and that's basic technology, and it doesn't work,
Right.
half the time. There's been two conferences I've been at where it was a giant room I was doing a presentation in, and something was wrong, and so I had to wait for 10 or 15 minutes for the tech that was running the computers that were set up in the room to come fix it, and I'm like getting further behind where I needed to be in a time slot, and it wasn't good. So I would never ever advocate for just turning over your data to the AI and let it figure out and just
Yeah.
check out and go home at the end of the day because it's going to make the right decisions. I think that's
Yeah.
never going to happen.
And sadly, some people I think will
Oh yeah,
because they don't care.
Yeah.
right,
They're just trying to get a paycheck.
right. Oh yeah,
And those are the people that, because then they can use AI as a scapegoat
Yeah.
yep,
Yep.
and
It's its
say,
fault, not mine. Yeah.
yeah, they can say, well, Siri made the wrong call, or Alexa, or whoever it is, they're the ones that made that call. I'm absolved of any
oh yeah.
wrongdoing here. So, in your travels with ReliabilityX, do you see a lot of AI being used in the plants now, whether it be with the CMMS, within technologies
Man, I'd
themselves,
say
anything?
I'd say more often than not, if they're collecting data, it's the wrong data. You
Okay.
know,
So it's more of a PM optimization
Yeah,
issue.
it's back to 101. Let's learn how to operate a wrench and a screwdriver correctly and make sure we have safety stuff in place. And like just some of the stuff I've seen is like mind blowing. I'm like one place I was like scratching my head. How do they even how is this place even still operational? It's just so yeah. We've
Yeah,
seen sensors that like are supposed to be collecting data for uptime and runtime and collecting hours for operation, and they have the sensor on the wrong side of the process. So, it's like on the in feed instead of the out feed. So they're
Yeah.
what they're showing that they're outputting, they're not. It's like it's just totally wrong. And like you can blame it on them. You can blame it on the manufacturer, the person that sold it to them. At the end of the day, both sides are equally sometimes not very competent in
right.
what they're
Yeah.
doing. So,
It's a
And
great point because, like, prior to AI, we've still had these fairly smart tools that we can all misuse
oh
and
yeah,
abuse and like use improperly. Well, now we just have somewhat of a brain. We're attaching to that, but we still have to guide that brain, and we're not there yet. So these can still be misused. But
oh
like
yeah,
to your point, what you're saying is like where sites are so far ahead or behind. It kind of depends on the sites. I asked one site as an example. Like I was just trying to get back history on their assets, and like, so where do you keep your like your bearing counts and things like your CMMS system? What is your CMMS system? And they pointed to filing cabinet. They're like, that's it. That's where all our history is on these
right.
papers in a filing cabinet. So even in this day and age, we still have places that they're not ready for AI yet.
Oh
They're
no,
not ready to use the tools we give them properly yet.
right,
But there is varying degrees for sure.
and it's kind of fitting, Paul, that you're down at your lake house right now when I bring this up, because every time that I'm in a doing an alignment training, I'll always ask them as part of it, hey, what's the first step of any alignment? And it's okay, maybe it's an I got you so question, but
right.
you know, and everybody will say, oh, get the old shims out, rough a line, clean it up. And they're all wrong. The answer is lockout, tag out. It's always going to be lockout, tag out, right? So I made a comment in one of my classes once, and it was down in Missouri, And I made a comment down there and I said, hey, what's the first step? And, I got the barrage of answers that I get from everybody that are all, okay, that might be the second or third step, but you kind of missed the glaring one. And I'm not an OSHA fanboy,
Right.
but we still need to make sure, we're not ripping our hands off here.
Yeah, you want to
And
go
I
home, at the end
said,
of the day, you want to go home with all your, fingers
right.
and toes and arms.
Amen.
Yeah.
And I said, and I told the guy, and he said it's rough alignment. And I said, no. And before I could get another word out, he's, berating me like I don't know anything. And I said, dude, step one is lotto. And he goes, Lake of the Ozarks? And I lost my shit. I'm laughing so hard. I'm like, so first off, you
Yes,
don't know how
that's
to
the
do an
first step.
alignment. Second, you shouldn't be working industrial maintenance if you don't know what lotto means.
Uh,
And I
lotto,
understand in the Midwest we call Lake of the Ozarks lotto. I
Well,
get
yeah.
it, but
Yeah,
I'm like,
and back
wow.
when I was working with the utility, and like I built all the job plans that we used at the water plant, and that was like step number one, lockout tag out. That was always task one, lockout tag out.
Yeah.
Isolate, lockout tag out. There was not a single job plan I had for anything that didn't have that in it.
And then always do, and people have different names for it,
Oh yeah,
but a go no go check or a test run check or whatever you call them. I don't know what else you guys have heard that called.
oh yeah. I was
A
trying to think.
test start. There's a lot of different
There's a
words.
lot of them.
I call them go no go checks, which is if I go in to do a service job, I want to see you hit that start button. And I don't want to see some operator click a magenta button on their screen that and they'll always give you a reason why. Yeah, but if I do that, it's going to file a nuisance alarm. I don't care.
Yeah, I know a dude that
I
got. I know of
put
a
the
dude
thing
that
in
got.
hand and hit the start button, and I want to see it, not start. Or I'm
Yeah,
not putting
I
thirty
know a
thousand dollars
place
worth of my equipment on it.
where I used to work. There was a guy that got in to do some welding on some equipment, and they had the local controls locked out.
Yeah.
The guy in the control room didn't know when he pressed the start button, and the guy lost his life because of it, because he didn't have it properly. Because they didn't do that test. They didn't say, "Hey, let's have the control room press the start button here and see what happens." And so it is important to do that and say, same thing. Just because the guy's standing around you can't push the button, or when they push it, nothing happens. But you got to make sure your remote control system doesn't have a way around that. Some places may never even tested that works right or not.
Yeah. It's important to have everybody involved, because there are sites where, like, if you're a contractor coming in and you go to lockout tagout, you may think you have it isolated, but if you don't have the right people involved that are familiar with the site, you may, just like what you said, a secondary type of source of energy that you didn't know about, even spring tension or hydraulics or things like that you didn't think about. I knew about the electrical, but I didn't know about this other stuff. Yeah. Yep. That's why really every site, any people going out there in any of these industries really should be working together. Communication is of utmost importance.
Absolutely. That was another thing we did at the utility. We for the longest time we operated the maintenance and operations sort of. We worked together during the day, but at the beginning of the day there was no communication back and forth what we were doing versus what they were doing. And we finally decided, well, hey, why don't we just meet together in the morning? We'll give out our orders and stuff to the maintenance guys with the operators there. That way they know what we're doing, we know what they're doing, and we'll get rid of all these problems. And that was huge. And they're still doing that to this day. So that was, that communication piece is super important, especially when it comes
really
to
is.
Because there's no job out there that I can think of, save maybe the military, that you should put your life on the line. Right. Just doing your run of the mill daily work. It's just nothing's worth it.
Well, hey, on a similar subject, not quite the same, but talking about like operations and locking things out. I had a conversation a week or so ago in a class where we were talking about one of the things, again, kind of a sidebar, but when you have buddy pumps or buddy systems, you got an A and a B. And I was asking people, because I'm like, in my experience, I'm like, it seems like people don't want to run B. They don't want to run A. They like one. And I asked one of the operators in that class, I said, is there something behind that? And he said, honestly, there really is. It's so stupid, but he's like, we know we should be exercising A and B back and forth. But he said, my favorite's A. And he's like, I don't know if it's, what is that? Why is A my favorite? But that's one of the things is like B will sit there never running forever, and then when they need it, it's got maybe false Brunelling, and they
Yeah.
start up and it fails, shortly after.
Yeah, we had that
But
with our air compressors. We had two rotary screws, and they would primarily run one. They were supposed to switch them back and forth each month. That's what the operator, the boss, wanted them to do. And then they had a third reciprocating compressor that sat there. Most of the time, they never used it. I brought it up. Like, do you guys ever run this? Do you even know if it's going to run? I think you guys should get in the practice of valving this thing in, valving the other stuff out, switching to it, running it, a certain amount of time a week just to keep it lubricated inside, keep moisture out of it, and everything else. So I think they eventually started doing that, but it took some time. But yeah, a lot of times they're already doing so much. Their bosses have got them doing a million things to make sure that they're moving all day long. And then so sometimes it's a hassle to switch stuff if it's not a maintenance thing.
I could see that. But that was kind of the funny thing of this one was I had kind of noticed that, and I called this guy out and he said, I'll be honest, I have a favorite. He's like, even when I know B is okay, he's like, I like as soon as B is running, he's like, I can't wait till A is running. He said, I just feel better. And I don't know if it's superstition or what it is, but I thought it was kind of funny because I'm like, all the places I've worked, I'm like, it seems like that is the pattern that they have a favorite. It's like a kid. You say I don't have a favorite, but you're running that one all the time.
It's in the manufacturing environments I've seen since I left the utility. They generally do have a favorite because at the end of the day, it just works better. You don't have as many stops with it. And it's usually because the operators haven't been trained or enabled to fix some of those minor stops and losses. And those things, 2 minutes here, 3 minutes there, 5 minutes there, if it happens all day long, that's eating your lunch and you don't know it. And but I think that's really a super common in manufacturing settings. Utilities have a lot of redundancy because they can sort of afford to have it. So they might have 2 or 3 chemical metering pumps all do the same thing, and they can isolate those out, run another one, or switch to them. It's easy enough because it's once they started, it just continues to run. There's no start in the morning, shut off in the afternoon, do a changeover for the next shift. That really doesn't happen. It's just the operators changing over, just continuing to drive down the road they've been driving on for the last shift.
Yeah.
Because I run into that similar to that is here in my hometown. I do a bunch of work for the local water treatment plant. And we've got booster stations because where my town is, we're on a river. So we've got a bunch of really high banks, on one side of the river, a lot of booster stations feeding out. And all these booster stations have, primary and redundant. And I've went in to do alignments before for these guys, and they're excellent people to work with, but this equipment's from, pre-World War II, a lot of
Right.
this stuff. And you go in there, be like, hey, we need to align this. We know we have an issue based off the vibration data I collected or whatever. Can we just switch over to the redundant? And they're like, that thing's not going to run. It's like, then why do you have it?
Yeah, exactly.
If you know it's not going to run, at this point, is
It
this not
helps you
just a
sleep
complete?
at night.
I guess they're like, well, we have a backup that won't start if we need
Will
it.
it work?
It'll probably
No, but
it'll probably catch
we
the
sleep
building
better.
on fire if it tries to start up. But
Yeah.
Yeah.
I'm on I'm
so
on I'm on 2 of the committees with the American Waterworks Association for maintenance and reliability and asset management. And you talk about an industry that has a lot of redundancy, so they see a lot of overall uptime, but maybe not specific equipment uptime. So they lean on the redundancy a lot of times to get through, not knowing, hey, well, when this quits working, I'm gonna have some problems. you know,
and
but,
redundancy can
we're
really
trying to do some
skew a
more education
reliability
with that.
number.
Yeah.
Right. So, Paul, I'm gonna take this a different path here for a second. So,
Yep.
you've talked a lot about when you were in utilities,
Mhm.
and not everybody that's listened to this knows you and knows your background.
Right.
Tell us about a little bit because right now, well, first off, I'll just preface with Paul. Now, he's the senior reliability manager. Am I saying that correctly?
Engineer or
For
senior reliability engineer is the title.
senior reliability engineer for ReliabilityX. Um, you've been in this role 3 years.
About close to 3 years. It'll be 3 years in January 1st or
Okay.
something like that.
So, ReliabilityX, great things for the industry. George and Joe, great people. We're hoping to have them on someday as well. Really just an absolute wealth of knowledge for reliability practitioners worldwide. Paul, I don't know if I should say Paul was fortunate enough to find them or they were fortunate enough to find Paul, but anyway, the stars aligned and you know everyone's kumbaya now. But prior to this, kind of walk us through you know your foray, start to finish. I guess I would say Paul Crocker graduates high school. What does Paul Crocker do next?
Yeah,
How did
well,
you get to where you are?
I'd say wandered around aimlessly for a few years. Now, I've kind of been employed like it really almost unbroken since I was like 16. I didn't have obviously full time jobs while I was in high school, but I did work the summers, and once I graduated, there's not been a point where I was unemployed for even a day. But I think the first I was interested in being an electrician, and I had went out to apply with the IBEW, and I had sort of a week or two prior, I had walked in and put in an application like nobody really knows what a paper application is for a job these days. I didn't even know if they were hiring. I just went into the utility in the front door, said, "Hey, you got any job applications?" I filled it out. Put in there was micrographics. That's what I kind of did. So microfilm, microfiche sort of stuff, and looking for that. And then the day came to go out to the IBW, and I got a phone call from BPU. This time I'm still young. I'm not making much income. I got a wife and kids, and um, had been sort of getting frequently shut off from the utility for non-payment. So I was like, I get a call from him, and a guy named Tom Woods, and I'm thinking, all right, man, I hope I paid the bill. And he says, well, hey, we got your application. And this was like 6 months after I had put it in. Like I had even almost at this point forgotten I'd put it in. I was ready to go over to IBW and go through an apprenticeship and become an electrician or whatever. So then the guy was telling me during the interview, hey, well, we've got these in-house sort of apprenticeships for a lineman, electrician, carpenter, painter. And I'm thinking, well, shoot, like, I don't know that I've got the IBEW one yet. Yeah, I said I'd come over and, go through whatever to get in there. But the utility was a sure thing. It was close to home. So I opted to jump to the utility. And when I was first there, I was working in the microfilm department as part of records management and mail. So they were kind of all the same and running to different sites for that stuff. And then they had a job bid system. So they usually, when they were going to do a job or open up a role somewhere, they would post it internally. And I saw one for a fuel handler at one of the power plants. So I went out, I signed up for it, went out to look at it, and they were operating these big giant D9 in Caterpillar dozers and big giant rubber tire dozer and skid steers and backhoes and a railroad switch engine to pull cars in and out. And I was like, man, I've always wanted to know how to run that stuff. So I signed up for it and did fuel handling at like all three of the power plants for, I don't know, 13 years or so. And then I was like, this is kind of like okay, but at the end of the day, I didn't really like it. So I saw a job big come open for, actually, I got to back up here. I went out of the country to help with installing a drinking water system. I didn't really know anything. I'd done a lot of research. And this is still back in sort of the early days of the internet, 2003, 2004. And one of the
You
guys,
didn't chat GPT how to do
no,
it.
there was no chat GPT.
Okay,
No,
just
I don't think Google
didn't
was
check
out
with
there yet.
Grok.
Yeah, it was the AOL dial-up modem, and all that noise. And
Yeah.
if you had a 40 meg hard drive, you were somebody. And
Right.
so the group I was going with this church was going to Argentina. They wanted to bring this drinking water treatment system. All the guy knew that was told me about it. He said it's a concrete box about 3 feet tall. It's about a foot square, and it has sand and then bacteria and stuff grow in it. And people pour in the water at the top, and they get the water out. He goes, we really want to deploy that there because they don't have any water treatment. People get sick from the water. So I started to learn about it. I found out there was this guy named David Mance who had went to Africa and sort of saw this problem. He was an engineer, and he went back to Canada and devised this what he called a biosand filter. It's essentially a concrete box with tube at the bottom to collect water, and it comes up and out a spout. And he filled it up with sand, and then just, so there was always a water about 6 inches to a foot that sat on the sand. And if you wanted to get water out of it, whatever you poured in, you would get out the other side. Well, sort of how this system works is it develops a layer they call a decking. I haven't said that word in probably 10 years. But it basically, a biofilm forms on the top of the sand. It's got the sort of oxygenated water here in the sand. You can't really see it, but there's microbes and stuff that live on the sand within a few inches of the top. And then below that, there's sort of different organisms. So the idea is you could pour in this dirty, contaminated water that would into a concrete box. It would remove like the worms and the big sort of bugs that would never make it to the outflow of the box, and then through predation of the organisms at the top, they sort of take care of each other. But as it gets down further and you get to a environment where there's no oxygen, like those bugs will get exhausted because they're not getting enough food from above. So the very top layer does a lot of cleaning in the water. And in the outside, you get really a lot. I wouldn't say it's the quality of water we have, but if they stay with the same source of water and don't change their source and operate the filter the way they're supposed to, you got a device in your house that can run essentially forever.
It almost seems like a septic system.
It's got some. It's really a lot the same way our modern sand filters work. In fact, once I sort of got the technology and figured out how it worked, and I went to Canada to an organization called Cost and learned how to build it and deploy it, I brought that information back. I was working at the power plant, and across the street was the water plant. And I took it up there to the chemist. I said, "Hey, man, I think this is some cool stuff, but I don't really know. I'm just going off what I've learned anecdotally around this and what I've been trained with. Is this a real deal?" And I left him all the papers and stuff that I'd collected, and he called me back a couple of days later. He goes, "Yeah, it's almost identical to the process we run, except you're not using, chemicals to disinfect." He goes, "We have rapid sand filters that have the same exact sand in them. It's an underdrain system that pulls water out, and so at the end of the day, the treatment process is different. We're using chemicals, and we have a certain standard we have to meet to the EPA. When you're in third world and you got the muddy water out that's in the pit in the backyard or the rain barrel you've collected off the dirty roof, you don't have any options. You're either drinking that or you're doing some sort of filtering to clean it up." And he said, "Yeah, it's absolutely real technology. It's thousands of years old." He goes, "I think it's pretty neat." So I worked with him. I actually brought one of the filter molds I built up at the plant and the filter in the plant, and we were running the plant's raw water through it to compare it to the plant's rapid sand filters. And it did a really good job. It got the turbidity of the water, the particles that are floating around it that'll reflect light. It lowered those to pretty close to what the filters were running. It did a better job of polishing the water, which is kind of the color component of it. You wouldn't be able to see it with your eyes, but it was doing really clear, sort of white water as opposed to sort of a yellowish color that the plant was turning out. But it was really cool stuff. Anyway, so that was kind of my springboard to get in the water plant. And before that, I'd gone to college. I got a bachelor's degree in network and communication management, and didn't really do anything with it at the utility. But when they hired me up there, they said, "Hey, we understand you got an IT background, and we know you got hired in to be an operator here, but we really want somebody to get our CMMS system stood up. We bought Maximo when the plant was built, and we've got all assets and locations in it, but we don't have a storeroom yet in it, and we want to start using it, And so that's how I sort of got started with that stuff. And one thing led to another, and me seeking out more information. I found out about SMRP and all the other organizations out there that do stuff, and got to working with the guys, and we started the Kansas City chapter of SMRP, out of the water plant with some other local guys. And I just, as I went to more and more conferences and got to see more and more people, in those travels, that's where I ran into George and Joe, and sitting in the audience, not really knowing them, but listen to them speak and present. Like George was phenomenal. He's like probably one of the best public speakers I'd ever seen. And so I went up, made a point to go up and talk to him after, and developed a friendship with him. And then same thing with Joe. I'd seen Joe at one of the conferences in Florida, and he did an outstanding session. I'd never seen him before. He was funny. He had the audience laughing. He was like on point about everything that he was talking about, and even did a mic drop moment at the end of it. It was like, man, if I ever get to work with these guys, I'm going to take the opportunity because, like, I had literally hit where I was at the water utility, really highest I could go. The people ahead of me weren't moving, weren't going to be retiring. We were all the same age, so once they left, I was going to be leaving. So I was kind of stuck where I was at, and it is like all the stuff I've learned. If I don't step outside my comfort zone, take a little bit of risk, I'll never really do anything more than I ever do during the day. Come in and just write up work orders and Maximo, go hand them to the guys, deal with personnel problems, stuff like that, which not all that fun. But so they had a job opening and told me about it, and I'm like, all right, I can. With this utility job, there's nothing pushing me out the door. They're not going anywhere. Job security with them is like maximum. It's a lifetime job if you want it. But I was more interested in growth, and that's how I took the ReliabilityX job.
So you pretty much spent your entire adult life in reliability in some way or another.
Yeah.
It was just maybe not fully developed at the beginning. Would that be
Right.
fair?
Right. Yeah.
And then you just kind of developed into it.
Yeah, and I'm sort of more of a technical person anyway.
Sure.
I get off on technical details and data, and it's more interesting to me. I'm like, but that's a hindrance too. When I go up to do a presentation or stuff, instead of running off the cuff and just talking like we're talking now, I
Right.
want to make sure I got all my I's dotted and T's crossed. I don't want to say something stupid.
Sure.
So I don't do presentations really very well because of that.
I would disagree because I actually sat, we were out in that, it's probably been 3-4 years ago. I remember sitting out in Ashland at one of the SMRP chapter events for Iowa, Nebraska,
Yeah.
and you were presenting
Oh
in
yeah,
the
I guess it was in
auditorium.
that auditorium. Yeah.
Yeah. And I came in because I had left my booth and went in there. And I'm like, I was asked by a couple different guys. They're like, you can't just leave your booth. And I'm like, well, I am because Paul's speaking.
Paul's talking.
So
Yeah,
I'm gonna go watch. I'm gonna go watch what this is all about. And I'll tell you, man, you don't give yourself enough credit when it comes to the public speaking because you do a very good job.
Uh-huh.
And that's also the reason. And Brett, you can back me up on this. The reason we wanted you on as guest number one is because when Paul Crocker speaks, people listen.
Yeah.
And we wanted you on here
I
for
hope
that
they
because
listen.
yeah,
you're
absolutely.
you're vice Sherpa, as we call you.
All right.
I don't know if that's the right term, but
Hey, it's good enough.
it's been because you and we've known one another probably 8-10 years,
Yeah, I'd say about that long.
I would guess. Paul's bailed me out of a lot of jams over the years. Brett, you were involved in one of those.
Oh yeah,
I think I remember that. Yeah,
I remember
some
that
kind of
quite well.
ultrasonic tool or something.
Yeah, an
Yeah.
ultrasonic tool that
Yeah.
dumped out on us down in
Needed a
Kansas
battery
City.
or
Yeah.
something. Yeah.
Yeah. Thank you,
And-
by the way. If I
Yeah,
didn't,
yeah.
thank you. Thank
yeah.
you.
Brett calls me up and he's like, "Man, I'm at the customer site. This tool like just will not turn on." And I'm like, "Call Paul.
Yeah.
He's got one. I'm sure he'll let you borrow it."
Yeah.
So got it all taken care of. But yeah, I mean, over the years, it's been a lot of fun learning from you a ton. And I feel like the things that you bring to the table, just with reliability in general, not any one specific thing, are paramount for all these different industries. I know you came from water, you were very specialized in water, but reliability transcends
Oh yeah,
all
it
those things.
touches everything.
And people, and it's so funny, like you'll talk to people, or I should say I will talk to people about, it's like, hey, do you know Paul Crocker? And they're like, I know the name.
No,
Everybody knows the name. They're like, I don't know him, but I know the name.
no,
And I'm
no,
like,
right.
as you should. It's kind of like nobody actually personally like has ever met Jesus, but they've all heard
They've
the
heard
name
him.
at some point. I'm just saying, I've heard of that guy, but not that I'm comparing you to Jesus, Paul. I'm just saying,
Wow. Big shoes to fill.
I took a leap there. We're the Beatles, but
Well,
Anyway,
I do have a question.
Yeah.
Talking about your past and stuff. One of the things, of course, Adam and I are more into the uh, data collection and analysis part of things, like the predictive world, the tools, the
Right.
infrared cameras, the ultrasound, the vibration stuff.
Yep.
We're kind of more into that part. You've kind
Right.
of branched off into some other areas that would be great for us to know too. But the question I always like to ask people, because when I got started, I think back what got me into this, and like what you're saying, it really kind of hits home. I actually have a similar background. I did get into the IBW. So
All
I
right.
was lucky enough I got in there.
All
So
right.
that was my first start. But I digress. The question I wanted to ask was, like, I remember the time when I got my hands on my first predictive tool,
Mhm.
and it was an infrared camera. And that's when I got it, and I started looking through it, and I'm like, I knew then, I'm like, this is what I want to be in.
Oh yeah.
Do you remember a certain technology that kind of got you like, this is exciting?
Yeah.
This
Well,
is what got me into it.
frankly, all the technologies, and I think I've always liked tools. I like shiny. One of my buddies at the utility says, "Oh, it's got shiny, blinky lights on it." He probably likes it.
Tools, we call them toys too.
Yeah. It's like I do like my shiny toys, and I usually like the
Raccoon
best.
Crocker.
I usually like the best I can get my hands on,
Yeah, oh, absolutely.
which was kind of always hard to do. But I think my boss would gripe, and he would say, "Well, how come that's not running?" Or like whatever. He'd want to know why something, like I didn't have a good answer for him. He'd say,
Yeah.
"Well, get the vendor to come out here and look at it and figure it out." So they'd come out and look at it. Most time they didn't know either. But once I started getting some tools, and I'm like, hey, dude, I can see this is going south. Like, we need to get
Yeah.
something done. Like, one of my first tools really wasn't even a tool; it was just oil analysis and pulling oil samples from stuff and seeing what's going on. And then I found out, well, this is pretty cool. I can see, hey, the last 4 or 5 I did of this, I didn't see any iron. Now I'm seeing like 150 parts per million. So I'm like, did we pull the sample wrong? Went and pulled another sample and got the same exact thing. So I'm like, all right, well, let me call the vibration guy out. So we had a stage 1 or 2 bearing failure happening, but it was because of shaft current and EDM damage, to the bearings, causing floatings and stuff. But as I started putting stuff together, it's like, wow, you can use, like, these tools are all good on their own, but like when I'd come to my boss with just one tool, he'd want like, well, let's verify that with something else. And like, so there, once I started seeing, okay, well, there's infrared, I got an infrared gun, and got ultrasound. I was like, well, I'm not that great with math, and vibrations, like, going to take a lot more time to learn. Ultrasound, like, I go out and start using this today, finding stuff. And I was always like using on stuff that I'd never used it on. We found that we could put it on our valves in our chlorine system. We'd find we have a leak somewhere. It wasn't leaking out in the room, but we'd see like a tank was getting wider that shouldn't have, or maybe one of our chlorine evaporators was getting chlorine in it when it was a vacuum on it for service. And I'm like, I couldn't really use infrared because it wasn't really something I could see, but I put the surface mount ultrasound tool just on both sides of that valve, and I could hear it. I'm like, dude, had no idea that it was leaking by the valves and stuff. So,
that's cool.
I just like tools for finding stuff. I always like things. We had, excuse me, I've had trying to recover from some allergy problems.
It'll fix that problem.
Yeah,
Dickel 8 year.
One of the issues we had at the utility at the water plant, and it plagued us for a long time. So we had all our filters. Water comes in, gets filtered, goes to high service, gets pumped out. Well, it comes back into an area where we called the combined clear well, and it's really where we took all our sampling of the water. We checked it for pH and temperature and turbidity and whatever other else. It's kind of where all our sample points were. One particular sample point for our turbidity was prone to get these like spikes. You get a spike here, you're supposed, excuse me, you're supposed to be under like one NTU, and we get these spikes that take us up, and the operators start panicking because now we're out of compliance. We got to go see what's going on. Now the filters were doing this, so it was like odd to me that this was coming from the combined clear well. So this took like years to figure out what this problem was. We had the turbidimeter company come out, their experts look at it, they couldn't figure it out. We had some engineers come out and look at stuff, and I've got this tool. I'm sitting here looking at it one day, trying to consider, man, what am I not looking at? Well, the pipes for this combined clear well were like 5-6 foot diameter. They were way down in the basement. So the filter's like way up in the air, and this pipe is way down here. And I'm like, well, I remember every time I like fill up a glass of water or something, like even though I'm not pumping air into that water, you can see the water going into it, pulling air in with it, and you see the bubbles coming up. I'm like, well, maybe that's happening off of these clear wells as they sort of feed into this main one, and we're getting just air coming through the pumps hitting that water bubble and breaking up into a million little bubbles, and we see it come through the turbidimeter. But I had no way to prove it. And I was like, man, it's a solid steel pipe. I can't do vibration analysis on it. I mean, maybe I can hear it with that. I don't know. I didn't try. But I do have ultrasound, and I know you can hear turbulence and you can hear, bubbles popping and stuff. So one day I went down there. I found out I went to the point where we drew it out from the pump and pumped it up, and I put the magnet on the pipe and listened to it, and you could sure enough hear. And like, okay, well, I moved it to a different point. So I started drawing dots on the pipe with a dry erase marker of what the reading was at that point. Moved it all around. Eventually found what was coming around from the corner from one of the clear wells was drawing water in. Well, the point on the pipe where it was tapped at was here. And I could hear that down here below this, there was no noise coming along the pipe. Imagine the pipe's like this. I could hear no noise, but as I got up to where that point was, that sample point and up, I could always hear the air bubbles going through. So they had tapped the pipe too high for one, and they were picking up the air that was coming around the corner from the clear well ahead of it. So I'm like, okay, well, this is good. So now I know where it's coming from. I got my proof. I wrote the numbers down, took some pictures of it. I was like, how do I address it? I know I can find a pump that can deal with air. I don't know how well. They're usually more expensive, like $4,000 or $5,000. My boss wasn't going to let me just change out one of those. What could I do? I'm like, all right. So I developed a plan. I had one of my mechanics that I could trust and work with. I was like, all the bigger bosses were gone. I probably shouldn't tell this, but all the bigger bosses were gone. So I'm like, well, hey, I can just do stuff when they're not here. So I said, let's disconnect this pipe. I want to get some clear tubing and connect to this pipe out of this outfall. And I got like a 1-inch tube so we could see if air bubbles were going through it. And I showed my flashlight. It was exactly like this. I had the pipe, and I was looking like this, looking for, air bubbles to go through. And there went one big one, 2-3 big ones. I'm like, what we need to build is a weir. So in a weir, we got the water coming in here. Say this is like the weir. Water coming in here. This is just an empty tube. And our pull-out point's down below that. So what this weir would do is the water would come in here. The bubbles would go up top, and we could pull from the water down below it that didn't have any air in it. So we tested it out. We got some clear PVC pipe, built a pipe, probably 10, 15 feet up in the air. We wanted to make sure we were past where the head level was for the water. So you can see the water level fluctuate in the pipe, which is pretty cool. You can see the bubbles going up, and they have now a way to get out. And that solved the problem. They had not had a single turbidity problem. And those turbidity problems were like 2 or 3 times a week. And it was like, get the techs, go down there, put that turbine in a hold so we're not getting that on there, and make sure the thing's clean. Like, it was all sorts of chaos all the time. Once we did that, that problem went away.
That is cool. That is a good example of use of these tools where, not traditionally, and even in the classes you go to learn how to use it. And there might not be the people that know that.
Yeah, and then I learned, in the process of doing that, that's a one-time change. We talk about reliability. When you want to change reliability, you either go back to redesign, do a one-time change. That was a one-time change, and that one-time change fixed that problem. So,
and Brett,
that's cool.
You and I had that one time. It wasn't work related. But remember, we kept losing CO2 on the carboy keg.
Yeah.
Brett and I brew beer occasionally in the winters when there's not much else to do.
Right.
We were losing carbonation terrible on a carboy, and we're out there with the soapy water bottle, trying to figure out where it's at.
Right.
Like, I've got all these super high dollar ultrasound tools in my office. Let's use them.
Right.
So that same tool that we borrowed from you found that leak.
Yeah.
Yeah.
Well, and you made a good point too, is like, supporting our data with other tools. There's
Yep.
more than one tool out there for predictive, and I
Yep.
always preach that whether I'm teaching a vibe class or a lubrication class or ultrasound, whatever it may be, I always bring up the other ones because it's like if you were a mechanic and you were only given a crescent wrench. Yeah, you can make it get by with quite a bit of things, but you sure feel better when you have these other tools to use. And it really does. For the analysis guy, when you're trying to figure out what the problem is, if I can back it up with other technologies, I feel so much more
Oh
comfortable
yeah.
doing so.
Yeah, I never really trusted. I was never really trustful of one technology all
Yeah,
in and of itself. I whenever
sure.
I could, I always did a second verification with something else.
Yeah,
Like if I saw when I got an oil sample that came back bad, I would go look at my data that I collected with the ultrasound tool and see if I'd seen anything trends in there that I recognize. And if I didn't see
yeah,
anything, then I called the vibe guy to come out and do stuff. And usually we'd find stage 1 or 2 bearing faults. And then the cool thing about that is it wasn't all right. Well, we got to shut it down. It's like, well, I had filter systems, so I'm going to see how long I get this run. I know one big 500 horsepower motor we got to last 2.5 years before we decided to pull it.
hmm,
And it,
yeah,
I was doing more oil analysis on it, checking it, filtering it, making sure it was clean.
yeah,
But it was on a big VFD drive, and um, just the nature of those drives can sort of help damage bearings. So, um,
yeah,
you get longer run life, and then you get to plan the outage. You get to budget for it, and it's a lot more safer than oh man, stuff's happening. We got to go get people. Call them up in the middle of the night. We got to get this going. Which
yeah.
you never really want to do.
Well, it's refreshing hearing you say some of the same type of things I try to say in class because, like what you're saying too, is that's the other hard thing to teach people is like when we're talking about predictive and reliability, like we want to be, let's reference that P to F curve. We want to be as far to the left on that P to F curve
Yep,
as we can be so that we have time to plan and schedule.
absolutely.
And I've had people say, yeah, but here's the thing. You say that if you can find it with vibration or ultrasound or whatever it may be, I can find this, let's say, bearing fault early. I still have to shut it down to replace it. So how am I saving money? But that's the whole point is if I'm far on the left-hand side of that P to F curve, I have
You got
time
time.
to plan, schedule, get the parts there, get the people there, all
Yep.
kinds of different things. Whereas if I let it fail, first of all, it's going to fail at the most inopportune
Always.
time.
Always.
Secondly, you may not have the parts ready or the
Right.
people ready because sometimes you have a special crew that has to replace this particular type of part or
Yep.
whatever it may be. So, and plus, if I let it go to failure, that one bearing might turn into 2 or 3 or 4 on down the line. Because here's the other thing, which you guys can chime in on this if you want to, but these flexible couplings, people are like, oh, I don't have to do alignments anymore and we're good. I'm like, that flexible coupling, it lasts longer, but the bearings don't around it
Right. Oh
because
no.
it's going to stay longer, but those bearings next to it are going to fail. So it's just, but I'm glad it's refreshing to hear somebody else say the same things that I
Okay.
preach all
Yep.
the time. So
I teach it all the time in alignment class. When we do an alignment, we are aligning at the coupler. We're not aligning the coupler.
right,
And there is a very distinct difference between at the coupler and aligning the coupler. Because if anything fails, I want it to be the coupler, right?
yeah, that's cheaper
Yeah,
usually,
it's no, not always, but for the
most of the
normally. But by definition and alignment, we're making the rotational center line of two independent shafts collinear under normal operating conditions. And people always think it's like we're just aligning this coupler. No, you're not. You're aligning asset A and asset B.
Mm-hmm.
right.
There's bearings, there's shafts, there's air gaps, there's
Right.
stators, there's rotors, there's everything else to worry about. So it is nice to hear somebody else say that
Yep.
Yeah,
Yeah.
because
We even had some chemical metering pumps that they were there during the start of the plant. This was in 2000 when I left 3 years ago. They were still there, but we had started to see it. They had an actuator. The control room could either adjust the speed of the pump up and down, or they could move the head sort of in and out to get more stroke and whatever to pull more chemicals. Well, we'd get these like actuators on the ends, and we'd find that they were getting their shear pins broken. And I'm like, well, I can't see anything. There's no really good place I can just stick my ultrasound tool and listen to it. Everything's all kind of real tight and compact on these. So we ended up rebuilding them and found out it was just bearing looseness that had occurred over the 20 years of running that was causing just a little tiny misalignment in that shaft is enough to make it bind up in the tube. It would go in and break that actuator. Well, those things were a pain to change. They were not fun for electricians, weren't fun for operators. Luckily, that was where our redundant equipment helped us get around them. But once we found out that was the issue, we brought all the parts in. I built a bill of materials for all the assets we had and had those, so we were just going to methodically go through them and rebuild every single one of them and hopefully get another 20 years out of them because they were workhorse of machines. But,
one other topic I like to bring up a lot too is criticality assessment, like criticality list for machines.
Mm-hmm.
How important do you think that is for making sure you got the right things on the right routes and things? Like, is criticality assessment, is it done once and you just let it go and is what it is, or is it an ongoing thing?
I think it's sort of like asset management plans. If you just go through it once and stick it on the shelf, it's really not going to do you good. Every time you make a change in the plant, you've changed a variable that would have been on that, in that study. You've probably gotten in new equipment and you didn't consider adding the new equipment. You've had people retire that knew certain things.
Yeah.
Then those people are no longer there, and the new people haven't experienced all the problems yet. So, I think they're sort of a continual process. So, if you got your EAM or CMMS system stood up right to collect the right data from the failures, and you got a good analyst that was looking for the right things and listening to the operators, what they're telling them, and listening to maintenance, what they're telling them, it goes a long ways to making sure you're doing the right maintenance. But I think that criticality is absolutely a high priority on the list for knowing what to work on and not just, hey, the light bulb went out there. Let's all hands on deck to go change the light bulb. So
it's a little more of a living document than hey, we already did it 10, 20 years ago. We did it.
They don't have to be. I mean, I know people can drag them out, but the ones I've been involved in are just process FMEAs. What all the stages here, what's it doing, and once you get in the groove with the people in the room, the operators and mechanics, you see them starting to realize the benefit in it, and then they get excited, and the input gets better and better, and before you know it, you've knocked out one machine in a day, and next day you knocked out another machine. It's like you get in a pretty good groove if you are doing the right things with them.
And I feel like it is important to have the right people involved because I've seen
it can't just be engineers, it can't just be the mechanics, it can't just be electricians or just the operators.
There's some people that know the criticality that have been there for a long time.
Everybody's got a different perspective. Like nobody's got their own perspective of everything. It's
exactly.
If you need 6 people in the room, but they can't all be purchasing agents.
Right. Yeah, exactly. Or safety, because I know safety's important.
Guys,
those guys are always going to say this is the utmost important critical machine because if it fails. But awesome.
Well, I feel like we talked about a lot more than I even planned on tonight. Paul, would you be willing to come back on at some other time and
always
pick up the conversation where we left off?
Yep, always.
I feel like if we go much longer, we're going to be having people log out just because
they'll put this on to fall asleep to. So we got to be careful.
So this is an ASMR podcast. But Paul, very much, dude, I really appreciate you getting on. It's been, I've known you for a long time, and I appreciate everything you've done for us over the years. Thank you for doing this as well. It's great to have just such a wealth of knowledge come into the podcast because that's not something that a lot of guys can probably say that they're lucky enough to get. So appreciate you very much. Here's a dickel to you.
Cheers.
Cheers. Thank you. And make sure for anybody who's listening in, appreciate that. Tune in to on the YouTube on the YouTube podcast link at ReliabilityU if you want to see the full video. So appreciate you guys.
You can go right to your reliabilityu.com now. There's no need to even drop in www.
And thanks to Paul Crocker, he fixed our website. So if anybody wants to check us out, it's reliabilityu.com.
Yeah, no need to hit the www or anything. Just reliabilityu.com.
Awesome. Thanks, Paul.
Yep.
Paul, thank you. Enjoy the late. Hey, and tell Michelle that we said hello.
I'll do that.
I saw her walking behind you a few minutes ago. So
all right, I'll do that.
Tell her hey.
All right, we'll
Appreciate it, man.
see you
Night,
guys.
bud.
All right.
All right.